Hey, welcome back to the fourth part of our simple note app using Jetpack, Compose and Room. In this video, you will learn how to test Compose UI using Compose test rule. We will write Android instrumented tests to run our tests. During the test, we want to make sure that the correct Compose nodes are being displayed on the screen and that interacting with the UI leads to the correct results. For example, clicking a specific button opens the correct screen. This is how running the test would look like at the end. Alright, to test your composable functions, you need to have the compose testing dependencies added to your project. To make things simple, you can clone this project on the GitHub, which has all the dependencies. Otherwise, you can just watch the video and try it on your own project. Alright, I have the Noteroom project open in Android Studio. I have made 5 tiny changes before testing our project. The first change is that the nav host is now moved in a single composable function out of the main activity. This way, we can simply test that function by passing a mock viewmodel to it. This function is in a file called Noteroom app under the UI package. The second change is that main activity is also moved to the UI package. The third change is that the old Noteroom app file, which used to initialize Hilt, is renamed to Noteroom application, so it has a different name than the Noteroom app. This was inspired by one of the Compose official examples called JetNews, if you know that project. There is also a new file added to the project. That's the fourth change. This file keeps the test tag constants. Tags are simply strings that can be attached to the modifier of composables. Inside the test, we can access specific composable by their tags and perform tests on them. The fifth change, last but not least, we need to add an Android test file in our project to write our tests. All these changes are available under branch number 5. Under Android tests, under UI package, create a new Kotlin class. I called it Noteroom app Android test. Then add the compose test rule as described in the documentation. Now, before we write our first test, please pay attention that we only want to test the compose UI here. In practice, we want to test the composable function Noteroom app, which depends on the view model. What we don't want to test is, however, the view model itself. That means we have to create a mock of the view model to keep those two separated. In this project, we have an interface created as an abstract for our view model. We can simply create an object that implements it. And then we can write our mocked behavior for its methods and values. On top of mock view model, you can see a fake node state and a fake list of nodes. This helps me to replicate the view model's behavior once and reuse it in each of the tests. In real view model, the changes to nodes happen in the real room database. But here, while we test, those changes happen to our fake node list only. Well, you might think that might be too much work for creating a mock, and there is another simple alternative that you can use. For example, using a mocking library for Kotlin such as mock-k. Mock-k is a great library that comes with support for Kotlin out of the box and is one of my favorites. It can reduce the code for creating the mocks and has incredible features for testing Kotlin coroutines. However, using third-party libraries might come with a tiny cost. It might reduce your control over the mocks while debugging. Or maybe sometimes, if there are updates in the library, it might require you to change some parts of your tests. My code for this project is very simple, so I'm not willing to change things often in the future. Therefore, for now, I will stick to this manual approach. If you're interested in using mock-k, please let me know in the comment section, and I might create a new video to cover that as well. The setup method is annotated with @before, which tells the test framework, hey, run this method before each of the tests. We simply want to reset the value of the selected nodes and the list of nodes, so it is clean for the test. If we don't do that, the values remaining in there might cause the test to fail. Now, in our first test, we simply want to know if the nodes are displayed or exist. First, we use the compose test rule.setContent to show a composable method. So I wrote NodeRoom app here, passing the mock view model we created earlier. After that, the home screen should be visible. Therefore, I make sure if the Add Node button exists. The nodes have test tags set for their modifiers, and I can use those tags to access them using compose test rule .onNode with tag and perform the assertions on them. For example, here asserting that the node add button exists. If it exists, I also click on it to open the notes screen. On the notes screen, I will also make sure that the items exist there as well. This way, if the UI changes in the future, you can always make sure that the key parts of the UI exist here by simply running the test. Now in our second test, we add a node and check if it's displayed on the home screen. We can simply click on the Add Node button using perform click, and then use the perform text input to write in the text field. Since the notes screen shows a list of items, to access the nodes I am looking for, I will use the onAllNodes with text method to get a list of all nodes with that text, and then assert that only one node exists with that text. After that, we want to edit the node and make sure that it is also edited on the home screen. To do that, simply perform click on the node and perform text input on it again. This will append the current text, then perform click on done icon to save it. Now in the home screen, check if the updated text appears. Perfect. In our last test, we want to make sure that the swiping on a node on the home screen will call the correctViewModel method to delete it. We currently implemented this behavior in our mock and is ready to test. For this test, similar to previous test, we quickly add a node and return to home screen. In home screen, on the node with text of the node, we perform a touch input with swipe left. This should remove the node from the fake node list, and since that was the only item in the list, it should be empty. We will assert that using Google Truth library. Please make sure to have the dependency for Google Truth library added to your instrumented test dependency. You can also find this dependency in the dependencies of the project. I hope you enjoyed this video and hope to see you again. Thanks, bye!